core body temperature is a very important parameter, probably one of the first health parameters you have. So when you go to a hospital or to your doctor, they measure the blood pressure, they measure the heartbeat, and also, of course, they measure the core body temperature, usually with a single device. And so nowadays, everyone is talking about saving healthcare costs by reducing the labor of the healthcare professionals, so the nurses and so on. And how is this going to be done? Everything is going to be packed in a patch or in a device which goes to the body, and where you then can measure ECG, where you can measure blood oxygenation and all these kind of things. And then there is one parameter missing, and this is the core body temperature. So everyone thinks that the core body temperature is quite easy to measure because it was one of the first parameters to measure. But on the skin, it's quite complicated. So you have skin temperature, and the big problem what you have with the skin temperature is that it's not core body temperature, so it's not what's going on inside. And you go outside, for example, or a patient decovers themselves, and immediately the skin temperature goes down. So it goes under the cover again, and it goes up again. And this is the biggest problem. And there we have a solution with the Calera technology. So greenteg is developing sensors. So we have tiny little sensors like this one on the finger. I'm not sure if you can see it. And these sensors, they are measuring the thermal energy from the body. So we are losing around 50 watt per square meter. Now we use this type of sensor exactly to predict the core body temperature. So we combine it with a temperature sensor, and then you can imagine what happens. So you uncover yourself, the temperature, skin temperature goes down, but the heat flux at the same time goes up. So what we have now is a nice compensation mechanism. So this tiny heat flux sensors knows exactly what's going on in the vicinity. And it's very, very sensitive. So it's 1,000 times more sensitive than any heat flux sensor on the market. That's why we make it so tiny, and you can even place it inside the device without touching the skin. So it's sensitive enough. And now with this nice compensation mechanism, we can then predict, or we have a nice data stream, which we then can predict the core body temperature. And we are providing it to many industries. So not only the health industry, but we also have a sports device, and we have, or a sports solution, and we have algorithm for firefighters, and yeah, of course, measuring and tracking fever in different kind of situations. We are there just on the border of AI. So when we started to develop the technology in 2015, we had a classical algorithm. The classical algorithm worked quite nicely, but it was dependent on each person. So we had to make a calibration, an in-ear calibration for each person before the start of this classical algorithm to get this main parameter out. But then, I think in 2018, we came up with AI. So we were taking a lot of measurements with reference temperature. We still use the classical algorithm, but as a data stream, with additional data stream. And when we had enough data and enough reference devices and reference data, then we were really able to overcome this problem of the calibration. So now we can really use the device or the sensor or the solution for every person. And this is a great success, and it was only possible thanks to AI. Core body temperature is our main field, and we will stay in there. So we are thermal experts, and we will provide the core body temperature to 4 different applications. But now we can provide it, for example, as a chip, but also we are now forward integrating it into a device. This device was first used for just measuring the core body temperature in the sports field. So it's the brand Core. So all sports people in the endurance sports, professional sports market are using this device to measure the core body temperature and to increase their performance. Now the next step will be that we are going through FDA and medical CE, and that then we can use the same device also for tracking fever for particular niche applications, for example, monitoring at home, monitoring of babies, and so on. The other path we are going is currently we have algorithm for wrist, upper arm, and chest. And this algorithm we will further improve. On one hand by collecting more data, but also we will expand to different positions. So we have a lot of requests, for example, for forehead, or maybe also for ankle position, but also then for other type of humans, so like babies. They have a complete different signature at the skin than an adult has. And we are heavily investing also into baby algorithm for the different positions.